Function approximation. A function's approximation as polynomial function. Any function approximation as polynomial function that for the one independent variable and multivariate variable. So we have provided the theorem proof. So theorem proof is done, and that is that what we have proposed. So that we will file disclosures or we'll try to make more towards it. But now we will consider more in the kind of okay. So we will consider more in the sense of called critical, called closed area, closed region, bounded region, unbounded region, local maxima, local maxima, global maxima. Okay, if time permits, then we will see few real life example of multivariable maxima and minima. But the main idea now is that what is closed region, closed interval. So if I have now takes two dimension, x axis, x axis, y axis, x axis, y axis. If there is x axis and y axis, then per x, if I have x, per x I have y value. If I connect all y value, then it becomes a curve. If I connect all the y value, then it becomes a curve or it becomes a straight line. Straightforward. Now that curve can have any moment the curve, the dy by dx, the rate of change in the curve, not change in the curve. Curve is changing very nice. Rate of change means per unit change in x brings how many unit of change in y at particular x. Rate of change in y at particular x. So rate of change, if I have a curve, then at any moment I can see rate of change is positive, rate of change is negative, or rate of change is zero. If it is a curve like this, then it is also called extreme point or critical point. So at that point, dy by dx is zero. At minimum also, dy by dx is zero. Okay. Now, if I have an interval, if I have an interval, I have an interval. Like I have, generally I give example, like I have y equal to sine t or y equal to sine x. Now x is independent variable whereas y is dependent variable. Y is, if y equal to sine x, this proves that y is a function over x. The function, Python function, if I place x as parameter to the Python function, then it would return sine of the x. So I have a function fx, and fx would return the sine x. So fx equal to sine x, where x is independent and f braces x. If x is independent, then fx is dependent. Means y equal to sine x, y equal to fx. Y is a function over x. Now if we see sine x where x is radian, then it crosses 0 radian, and then at pi by 2 it becomes maximum. Before 0 at minus pi by 2 it becomes minimum. Okay, so at pi by 2 it becomes maximum, at minus pi by 2 becomes minimum. Let's then it goes and it becomes 0 at pi, and again 3 pi by 2 it becomes minus 1. Then it becomes 0 at 2 pi, whereas 2 pi plus pi by 2, it becomes maximum again. So sine x function, it's kind of, you can say that it does kind of, you can say that fluctuation, or it is kind of, it repeats itself. Okay, so if I have an interval from minus pi to plus pi, or minus pi by 2 to plus pi by 2, I have an interval minus pi by 2 and plus pi by 2. So if this interval minus, if I say interval between minus pi by 2 and pi by 2, interval between minus pi by 2 and pi by 2, how many maxima or minima are there between minus pi by 2 and pi by 2? Means I exclude minus pi by 2 and I exclude pi. Okay, this is an interval where the end line is not there. It is also called boundary line, that is at minus pi by 2 and pi by 2 I am excluding. If that is the case, and if I ask, then how many maxima and minima are there? Then 0. There is no maxima and minima. If I say I include I include minus pi by 2 and pi by 2 as boundary, then how many minima and maxima are there? One minima, one maxima. So interval with boundary, interval boundary along the boundary line, it is called closed interval. Closed interval. Interval without boundary, it is called bounded interval. Bounded means there is a center. From center, left side up to this distance, right side up to this distance. This is called bounded interval. From center origin, from minus pi by 2 to pi by 2. One side, it may include the boundary, but not both sides. If it includes boundary on both sides, then it becomes a closed interval. If it includes boundary at one side, it's all right. One side is open, then it is a bounded interval. Closed interval, bounded interval. That is the concept. So from 0, I take a distance of minus pi by 2. So I say minus pi by 2, okay, the whatever the x is, minus pi by 2, minus pi by 2, x is greater to minus pi by 2 and lesser or equal to pi by 2. If I say like this, then there is one maximum in the bounded interval at pi by 2. If I exclude pi by 2 boundary, minus pi by 2, x is greater to minus pi by 2 and less than pi by 2, there is no warranty that there will be maxima or minima, and it is not there. But if I include both boundary at minus pi by 2 and pi by 2, it becomes a closed interval. Then we have one minima and one maxima. But if I make the closed interval at minus pi by 4 and pi by 4, closed interval at minus pi by 4, pi by 4, do we have minima and maxima? Yes, we have minima and maxima, and that minima and maxima is, one is at minus pi by 4, that is minima, from where it will go rising, and at pi by 4 it is maximum. So closed region, a closed interval will have minima and maxima. Line where it enters the closed region, it exits the closed region. Between that, I have to check the lowest point and the highest point. That is minima and that is maxima. So closed interval will have minima and maxima. But the bounded region may have bounded region means if I take a point as origin, from origin up to this length, up to this length, up to this length, maximum this length. If I say minus x is greater to minus pi by 4 and lesser to pi by 4, greater to minus pi by 4, lesser to pi by 4, means from center maximum minus pi by 4, not including minus pi by 4, and up to pi by 4, not including pi by 4. How many minima and maxima are there? Then this interval, this interval excluding the boundary, no guarantee. Okay, like if I say that if I say that the left side is more, left side is minus pi by 2. I say minus pi by 2 means 90 degree. I say minus pi by 2, okay, or if I say in degree, then minus 100, more than minus 100 and less than plus 100. What will come in radian? How many minima and maximum? There is one minima and one maximum. Okay, so a bounded region may have minima or maxima. Possible. Means I see that line entered in the bounded region and then it decreases and then it increases. So that is minima. And then it is going maxima and then it is decreasing. So I have one minima or maxima. But in the closed interval, wherever it enters and wherever it exits, below, in between, whatever is the maximum or whatever is the minimum is minima and maxima. So closed interval will have a minima and maxima, whereas a bounded interval where may not be there can be one boundary, but certainly not the both boundary included. In that sense, we will have we may not have minima or maxima. There is unbounded region, unbounded region, like minus pi by 2, x is greater to minus pi by 2, less than infinity, or right side less than infinity, not less than equal to infinity, less than infinity. Okay, like let's take example of a parabola, quadratic equation. So y equal to kx square, then in that sense, or y equal to x square, in that sense, then there is a parabola like this, and if it is a parabola like this, then parabola is centered, the lowest point of the parabola is at origin 0 comma 0. Now if I say that I have a closed interval minus 3 to 3, means it includes minus 3 to 3, then what is the minima and maxima? Then minima I have at the minimum point, that is at origin, and maxima where it exits the closed interval. But if I have a boundary region, boundary interval, minus 3 to 3, x is greater than minus 3 and less to 3. If that is the case, then what is minima or maxima? There is one minima at the origin, but no warranty for the maximum, because it takes a range of the interval. Okay, so there is no fix that what is would be the maximum, because range is not fixed. It is up to by plus 3, minus 3 to up to plus 3. In that range, if you get to see maxima, it is very fine. If you get to see minima, otherwise no warranty for the maxima and minima. Or if I say that minus 3 to infinity, unbounded region, unbounded interval, closed interval, bounded interval, unbounded interval, minus 3, x is greater to minus 3, not including the minus 3. If x is greater to minus 3 and then less than infinity, not including the infinity, how many minima it has? Then one minima it has, and then not known. If I say from 0 to infinity, not including 0, then parabola has minima at 0. No warranty for the minima and maxima. But I have a closed interval. closed interval 1 to infinity, x is equal to and greater to 1 and less than equal to infinity. What is maxima and what is minima? So minima the where it enters the the closed closed interval, and plus infinity where there, if I know, then probably whatever I think can be maxima, I believe here maxima is also not defined because parabola would keep going. Okay, so there is no fixed point where I can say that here it is the maximum. But if it is kind of, if I say, if it is a sine wave, then certainly in closed region I can say this is maximum. So this is a kind of closed interval, boundary interval, and bounded interval, and unbounded interval. Closed interval where both end boundary includes in the interval. Bounded interval is where there is a center. From center I say less than this and greater than this. Means maximum up to this point it can go on left side. Maximum up to, so I can say less than minus less than means from left side it would go k distance and right side it would go k distance or k1 distance and k2 distance, not including k2 boundary, not including k1 value. If I want to include one of them, I can include, not both. If I include both, it becomes closed interval. So region or that interval where I have less than, where I have left side k1 and right side k2. So from k1 to k2, this is a bounded region. Or if I say minus infinity to plus infinity, then it is unbounded region because we don't know where it will go. But bounded region, I know maximum it would go up till here. But if it reaches minima or maxima, we include. Otherwise, we don't include. But in closed interval, even if does not reach minima or maximum any point, but wherever it enters the closed interval and where it exits the closed interval, these 2 points, if it is a straight line also, then this is maxima and this is minima. This is closed interval. Certainly there will be a minima or maxima in the closed interval. So what we are saying, whatever we calculate maxima or minima as per the differential equation where dy by dx is 0, and if it falls in a particular interval, bounded interval, then we have minima or maxima. Or in unbounded interval also, if it falls, then that is minima or maxima. If it does not, there is no minima or maxima that falls in a particular interval, but still interval is closed interval, then at boundary, whatever the minima or maxima, we take it as minima or maxima. So closed interval is certainly kind of minima or maxima because there is a boundary, and if a curve enters the boundary, that point we register the y, and it exits the boundary, that point we register the y. And if there is, if the curve is a straight, okay, then this is minima and this is maxima. If curve make a increment or curves make the decrement, then that is minima and that is maxima. So closed interval always. So closed interval is a new thing. Otherwise, whatever we are seeing, those are bounded interval or unbounded interval. Now, if I do dy by dx, and at particular x, if I get a maxima, extreme point, maxima, like sine pi by 2 at x equal to pi by 2, sine pi by 2, it is maximum. Then we call it local maximum. Now, term come, we saw now kind of closed interval, bounded interval, unbounded interval. And with unbounded and bounded interval, maxima minima can happen where dy by dx is 0. Then only we can say it is minima or maximum. But in closed interval, not required that dy by dx has to be 0. If the boundary point also we consider as maxima or minima. Now, if I do dy by dx, okay, so if I do, okay, so if I do if I do dy by dx, if I do dy by dx and dy by dx, it comes, if I do dy by dx and dy by dx comes as 0, okay, now I would run that this is extreme point. If this is extreme point and it is 0, then if that extreme point means the point what I am seeing like pi by 2, sine pi by 2, sine pi by 2 is 1, whereas dy by dx means sine dy by dx means cos x. Now cos pi by 2 is 0. So rate of change at pi by 2 sine is 1, pi by 2 sine is 1, that is true. But there is no rate of change that is seen at pi by 2. If that is the case, then pi by 2 at pi by 2 sine is extreme point. Now I see around pi by 2. If other points are lower to that point, then it is local maximum. It is local maximum. Okay, and at minus pi by 2, if I see other points are higher to at minus pi by 2, that is minus 1, then it is local minima, local maxima and local minima. Now I have a closed interval from minus pi by 2 pi by 2, closed interval. Now this local minima becomes global minima because closed interval means that is the universe. Beyond that, there is no universe. Okay. So if I say I have a closed interval from minus pi by 2 to pi by 2, okay, closed interval means x is less than equal to minus pi by 2. X is, I mean, x is greater and equal to minus pi by 2 and less than equal to plus pi by 2. Okay. Then inside that at minus pi by 2, I have interval. I have extreme point minimum, and plus pi by 2 I have extreme point that is maximum. Then these two are local maxima, local minima, global maxima, global minima. Because if I have a closed interval, that is the world. Okay. So if I have an interval and inside the interval, if I see something that is minima or maxima, what about I have a closed interval minus pi by 4 to pi by 4? Whatever minima I have, then at minus pi by 4 I have the minima and plus pi by 4 I have the max. Not required that dy by dx has to be 0 in closed interval. So then at that point, this is local minima, global minima, and this is local maxima and global maxima. This is closed. Whatever we are talking about, the actual maxima minima dy by dx equal to 0, that is the bounded interval. So in the bounded interval of minus pi by 2 and pi by 2, where we don't include minus pi by 2 and pi by 2, there is no minima or maxima because there is no dy by dx equal to 0. Okay, but if I say that I include minus pi by 2, one boundary, if I include in the bounded region, if I include minus pi by 2 and exclude pi by 2, then I have one local minima at minus pi by 2 or global minima at the minus pi, local minima at minus pi by 2. But certainly that is not the global minimum, in a sense that beyond the bounded interval we can have again minima or maximum. But if I see the equation of parabola, that is y equal to x square, and if I have bounded interval from minus 1 to 1 excluding minus 1 and plus 1, in that bounded region I have dy by dx as 0 at 0, then I have a local minima at 0, and since parabola keep increasing, beyond that I don't see any minima possible. So in this bounded region I have local minima and I have a global minima. Okay, what about local maxima and global? There is no local maxima, global maxima. But if I make that minus 1 to 1 as closed interval, then I have local and global maximum. But I have now local minima and global minima, because I know beyond that it is not going to converge anyway. But if I have a sine wave and it falls inside the bounded interval, then I have local minima or local maxima, but that cannot be global because it repeats beyond the particular interval. So that is a closed interval where we include the boundary, open open closed interval on both sides, or from one side, that is bounded interval, or if it goes till infinity on one side or both sides, then it is unbounded interval. Closed interval guarantee there will be maxima and minima, whereas bounded and unbounded interval, there is no warranty that maxima or minima will exist, because there is no warranty that in that region dy by dx will be 0. Irrespective of dy by dx 0 or not, in closed interval we have maxima or min. So that is kind of. Now we talked about two dimensions. Can we see? Or a single curve. What about three dimensions? I have xy plane. If I have xy plane, and then xy plane will have two variables, x and y, two independent. If there are two independent variables, then how things goes upon. Now interval, what we were seeing here, it is only one dimension, x. X is less than or more than or something like that. Okay, x. Like in 2D, I can give one more example, like y equal to 1 by x square. Y equal to 1 by x square. When x is 0, y is infinite. When x is 0, y is infinite. And when x is infinite, then y is 0. Okay. Now I have a bounded interval that is from 0 to infinity. I would say unbounded interval that is from 0 to infinity, not including 0 and infinity. How many maxima and minima are there? There is no maxima or minima, because maxima happens at 0 and minima happens at infinity. Before excluding infinity and excluding 0, I have the unbounded interval. But what about if I have closed interval that is from 0 to infinity? Then I have at 0 I have maxima, at infinity I have the minima. So this is something that is closed or bounded and unbounded. Now if I have 3D where I have xy plane, if I have xy plane, then same thing I would do. Now the boundary is on two sides, x side and y side. If this is x and this is y, then boundary is on x side and boundary is on y side. I can say x, okay, minus 3, x is greater and equal to minus 3 and less than equal to plus 3, whereas y is greater and equal to minus 6 and less than equal to plus 4. So whatever the region, now the interval term came to region. Whatever region we are seeing now, that is called closed region. If I exclude the boundary, any boundary or all the boundary, it becomes a bounded region. If I exclude any boundary and make it go infinite, then it is unbounded region. So that is the idea. Now if I have an equation that is z equal to, or fxy, z equal to 1 by x square plus y square, 1 by x square plus y square, where x square plus y square is between 0 and 1. Between 0 and 1. This is a bounded region. it excludes 0, it excludes 1, between 1 and between 0 and 1. If that is the case, now how it would be? fxy equal to 1 by x square plus y square. So when x and y are 0, then it is going towards infinite. When x and y are finite, then slowly it is touching the xy plane. When x is infinite and y is infinite, then it is 0. So from it will come like this, and it will go from both directions, it will go like this. So it will, if I show in 3D, then it will come and slowly it will become like this. Now, if I say closed region from 0 to 1, then maximum is at 0, that is infinite. So there is one maximum that is at infinite and one minimum at when x is 1 and y is 1. But if it is a bounded region, 0 and 1, between 0 and 1, there is no maxima, no minimum, because nowhere there is d2 where dz by dx and dz by dy both are 0, no. Okay, so this is bounded region where dz by dx and dz by dy both has to be, these expressions are not anywhere available. Okay, you will read about bounded region, closed region, unbounded region, but how it can happen, this much clear distinction that you need to have all the derivatives 0 and those kind of is not available. Anyway, if I have dz by dx and dz by dy, both if I set it to 0, means they both are 0 at particular point, then, and that is inside the region, inside the bounded region, then bounded region has either maxima or minima. Like if I say z equal to fxy equal to x square minus y square in a closed region, even it is a closed region, but you know that if I do dz by dx equal to 0, x is 0, dz by dy equal to 0, y is 0. At x0, y0, at that point the xz plane is like this, that is x square, and yz plane is like this. So at this point, xz plane has minimum parabola and yz plane has maximum parabola. It is a saddle kind of situation where there is no maxima or minima. Okay, so now if I see the closed region, so at particular x and particular y, one is going high and one is going down. One is going high and one is going down. So closed region, we have, certainly we have maxima and minima guaranteed. But here there is no guarantee. One side it is going up and one side going nowhere. At origin also, if they become 0, dz by dx and dz by dy, but it is neither maxima nor minima. So there are limitations where the closed region may not be maxima or minima. So in this kind of situation, otherwise, if the surface is a moving x and y component of the surface, they are synchronized with each other, means both have dz by dx negative, then both have negative. If dz by dx is positive, then dz by dy is also positive. Those kind of homogeneous scenario, then a closed region will certainly, it will have minimum or maximum. But the bounded region, it will have minimum or maximum only when where dz by dx and dz by dy both are 0, typical extreme or critical case. Or in the unbounded region, if it converges to dz by dx and dz by dy as 0 sum 1, there we have maxima or minima. But saddle kind of situation, certainly it is not decided, like cone kind of situation. Cone, if we see, then dz by dx and dz by dy, like if I take example of fxy equal to 1y square root of x square plus y square. If I do dz by dx, it comes as xy square root of x square plus y square. Okay, so I mean cone equation is fxy equal to a square root of x square plus y square, not 1y square. fxy equal to a square root of x square plus y square, that is cone equation. If I do dz by dx, it is xy square root of x square plus y square. dz by dy, y square root of x square plus y square. If that is the case, if I set it to 0 to get the extreme point, then x is 0, y is 0. Now at x is 0, y is 0. Now again go back and see dz by dx. It is 0 by 0 undefined, dz by dy undefined. So in this situation also either you have, even if you have closed region, but there is no guarantee warranty. Whatever is the normal rule of maxima or minima that prevails here. Otherwise, if things are continuous and likely to happen, like here it is discontinuous as far as differentiation is concerned. So if derivative is continuous and it is a kind of both are in same shape dz by dy and dz by dx, then certainly we will have maxima and minima as far as closed region. Region means xy plane is concerned. So what is the definition of a region? Of a bounded region. A closed region means minus x. Okay. So if I have a point, from this point this much left including the boundary, from this point this much right including the boundary, x direction, same in y direction, that region becomes a closed region. Closed region generally will have maxima and minima, even though we don't have dz by dx and dz by dy equal to 0. But in the, what is the bounded region? Bounded region is generally specified as I have a point, from point I draw a circle with radius k excluding the boundary curve, then that region is called bounded region. So bounded region typically it is a circle. I have a point x0 y0. From this point I have a k radius circle. A radius is k, and if I draw circle around x0 y0 excluding the parameter line, a curve, then whatever we see, that is a bounded region. If it is infinite, then it is unbounded region. Or if I draw a circle and I from x0 y0 I take only right side. From x0 y0 I take only right side, right quadrant. It is not a bounded region because there is no center I have taken. From center, and center is excluded, and then left side I have not taken. So there is no circle here. From center I expected there will be a bounded region. From center I took only right side. So there is no bounded region. There is a closed region but no bounded region. So bounded region has to have a center, and from center with k radius I have a bound circle excluding the bound. That is the bounded region. If I include the boundary, then it becomes a closed region. If I don't have boundary at all and radius is infinite, then it becomes an unbounded region. So in closed region, I have to have a minimum or maximum, because closed region 3D means surface enters and surface exits. So certainly there is minimum or maximum. If it is grows and comes lower in the region, then that is a minimum or maximum. So closed region will have, except some exception, it will have maxima or minima. But in a bounded region, there is no guarantee warranty that dz by dx and dz by dy will reach 0. No guarantee warranty of the maximum minimum. Same as unbounded region. So that is kind of, so same formula we can take fxy equal to 1 by x square plus y square, and where x square plus y square. So this example probably I gave. So this is kind of concept of, so whatever the, if I have a bounded, if I have a closed region, and inside that whatever the minima, closed region is the world. So whatever the minima and maxima we see, we call it local minima, local maxima, global minima, global maxima. But if I have a bounded region, inside that if I say it is minima, and I know that it is not going to repeat again this curve, then I can say it is local minima anyway I say, then it is global minima also, or local maxima and global minima. If I find local maxima inside a bounded region, but it would repeat again, and that I'm certain it would repeat again, but what would be the condition that I don't know, then it is certainly only the local maxima, not the global maxima. But in a closed region, whatever I receive maxima, that is local global maxima, local global minimum. But in bounded region, if I find any minima maximum, that is global local minima, local maximum. Like paraboloid, I know that if I found the minima, then certainly there is not going to be another minima. So this is local and global minima. Okay, but if it is a bounded region, then there is no maximum, because dz by dx and dz by dy is not zero. But if it is a closed region, then at boundary point there is a local and global maxima also. So this is kind of local and global minima and maxima, and then we have closed interval, bounded interval, unbounded interval, closed region, bounded region, unbounded region. So one is x-axis one, that is interval. One is xy plane, that is region. So this is what. So probably we will have a final video where we will talk about the maxima and minima through the constraint. Okay, I know that I have a particular point. If I take a unbounded region, okay, unbounded infinite to infinite, and then at particular point, if I have a particular maxima or minima, but not required that it suits me. I want maxima and minima, but inside a particular line, below the line, that is a constraint, or inside a circle, means inside a closed region. So inside a closed region or inside a bounded region, only I am looking for global maxima and means looking for maxima or minima, not anywhere else. If that is the constraint I am putting, then what can be the scenario and how I can find minima and maxima if constraint is concerned. So that we will see. Probably that then we can conclude maxima and minima. Then we will have very interesting one kind of topic we'll take, that we know that partial derivative along x-axis, partial derivative along y-axis. What is partial derivative along any axis? We have already discussed this, that partial dz by dx and dz by dy we can calculate differentiating x and y. What about dz by du, where u is any vector? So partial derivative along any vector, we will revisit it. We have already done. We will revisit it because we have now polynomial approximation of any function. Worth revisiting that partial derivative along any vector. So that we will